When people hear about the special demand from AI servers, the spotlight always falls on the star players like GPUs and advanced memory chips. But what today's news shows is that the heat of this boom has started reaching much deeper into the supply chain, all the way down to a plain, white, powder-like material that rarely makes headlines. The way I see it, the benefits of the AI boom are now steadily spreading into the materials industry, a field where Japan holds quiet but genuine strength. Today, I'll walk you through a news story that captures this trend perfectly.
Hello everyone, I'm Tai, with 31 years in the semiconductor industry. Today, I'm covering the news that Ishihara Sangyo, a Japanese chemical maker, plans to double its production capacity for high-purity titanium dioxide, destined for AI servers. By the end of this video, you'll understand the role of MLCCs, the tiny components working hard behind the scenes inside AI servers, and just how strong a presence Japanese companies command in the world of their raw materials. Please stay with me until the very end. Let me start with an analogy. Imagine a city experiencing an unprecedented construction boom, with gigantic skyscraper hotels going up one after another. Public attention naturally gathers around the hotel's glamorous exteriors and the big construction firms building them. The news covers only the flashy buildings, too. And this construction rush isn't happening in just one city. It's happening in many cities at the very same time.
But once the hotels actually start operating, problems appear in unexpected places. When guests all turn on their showers at once in the morning, the water pressure swings wildly for a brief moment. No matter how magnificent the main water treatment plant may be, it simply can't manage those instantaneous fluctuations the moment someone turns the tap. What actually supports the guests' comfort isn't the big facility far away. It's a mechanism much closer at hand. What absorbs those swings are the small water tanks placed on each floor. They hold just a little water and release it instantly the moment it's needed. They're easy to overlook, but without these tanks, a comfortable hotel simply cannot function. If there aren't enough of them, even the most luxurious building could ruin its reputation over a single shower. And the more gigantic the hotel becomes, the more intense the water usage gets, requiring several times more tanks than ever before. And the story goes even deeper. What actually determines a tank's performance is a special material used on its inner surface, and the extremely fine powder that serves as its raw material can only be produced by a handful of companies. Even if you rush to ramp up tank production because of the construction boom, without this powder, you can't build the tanks at all. In other words, the benefits of the construction boom don't stop at the flashy construction companies. They flow down to the tank makers, and further still to the powder makers deep in the background. Today's news is precisely about one of these powder companies in the back. From here, let me explain concretely how this simplified story is actually unfolding in the real industry. The main player today is Ishihara Sangyo, a Japanese chemical manufacturer. Titanium dioxide is best known as the white pigment used in paints and coatings, and Ishihara Sangyo has a long history in this field. Now, in response to expanding demand for AI servers, the company plans to double its production capacity for high-purity titanium dioxide. The expansion will take place at the production facilities of its plant in Yokkaichi City, Mie Prefecture. The investment totals 3.9 billion yen, of which 1.3 billion yen comes from a government subsidy. Supply is scheduled to begin in April 2030, which means this is an investment looking roughly 4 years into the future. The government subsidy is an important point here. It suggests that this expansion is positioned not merely as one company's business decision, but as part of a supply chain that the nation itself believes is worth supporting. So what is high-purity titanium dioxide actually used for? The answer? It's a raw material for the dielectric layers of multilayer ceramic capacitors, commonly known as MLCCs. A capacitor is a component that temporarily stores electricity. MLCCs are tiny parts that stabilize voltage and filter out electrical noise. And inside an AI server, they're mounted in almost countless numbers around the GPUs, CPUs, memory, and power supply circuits. AI servers consume far more power than conventional servers, so delivering electricity stably becomes a matter of life and death. That drives up demand for high-performance MLCCs, and demand for their raw material, high-purity titanium dioxide, grows right along with it. This is the chain of demand behind the decision to double production capacity. Every time demand for compute chips rises, demand for the surrounding components and their raw materials rises with it, link by link down the chain.
From here, let me dig deeper from a professional's perspective. When it comes to AI servers, the world chases only the star topics like GPUs and HBM. But what I believe truly deserves attention is that this wave of special demand has begun reaching materials several layers deeper than the star components. Behind every star product lies a long chain of materials supporting it. The way I see it, today's news is clear and easy to understand evidence of that flow in action. Taking one step further into what MLCCs actually do, they store electricity for just an instant and release it the moment it's needed. If the power supply unit is the power plant, the voltage regulation circuits are the substations, and the board's wiring is the transmission lines, then MLCCs are tiny electricity tanks placed right next to the GPU. They're not the stars of the computation, but you could call them the rapid response crew that keeps the stars working stably. And MLCCs for AI applications are astonishingly dense inside because they're required to pack large capacitance into a tiny body. The ceramic layers inside are around 1 micrometer thick, and in some cases even thinner. The barium titanate particles used as the raw material are in the 100 to 200 nanometer class. Once you get down to this level of fineness, the purity of the raw material and the uniformity of the particles directly determine the final quality. High-purity titanium dioxide is the upstream raw material for producing this barium titanate. In this field, Resonac is said to hold a large share in high-end products, and some observers estimate that Ishihara Sangyo commands roughly 80% of the global market when limited to AI applications. There are also reports that more than half of its current output already goes to AI uses. In this humble world of white powder, Japanese companies occupy the top positions. Here's my take. What deserves the most attention in this investment is the timing. Supply begins in April 2030. For a capacity expansion aimed a full 4 years into the future, the company is putting up its own money, and the government is adding a subsidy on top. To me, this is a sign that both business and government share the same view. AI server demand is not a passing boom, but something that will continue over the long term. That said, there are real challenges as well. Accurately reading demand 4 years ahead is no easy task, and if the wave of AI investment settles down sooner than expected, the expanded capacity could turn into a burden. Even so, the fact that they structured the deal to share risk through subsidies reveals, I believe, a clear determination to keep this material securely supplied from within Japan. Finally, the impact on Japan. Japanese companies stand out remarkably in this territory. In barium titanate powder, the lineup includes Sakai Chemical Industry, Nippon Chemical Industrial, and Fuji Titanium Industry, a subsidiary of Ishihara Sangyo. And in MLCCs themselves, Japanese players led by Murata Manufacturing lead the world. From raw materials all the way to finished components, the chain stays connected inside Japan. To avoid any misunderstanding, this is not a story about a flashy, gigantic market, and overestimating it would be a mistake. But the base of AI server growth has clearly begun reaching beyond GPUs and HBM, down to Japan's unglamorous electronic materials. The way I see it, this fact is a quiet but genuine tailwind for Japan's materials industry. Let me summarize. Ishihara Sangyo will double its production capacity for high-purity titanium dioxide. The investment is 3.9 billion yen, of which 1.3 billion yen is a government subsidy, and supply starts in April 2030. The target is demand for the raw material behind MLCCs, which are mounted in huge numbers inside AI servers. The benefits of the AI boom are now reaching not only the star components, but the materials hidden deep in the background. That's all for today. I'll keep bringing you semiconductor news and analysis. So if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.